Okay, I've been a silly Billy. I forgot to press the stop button in the lecture theatre earlier, so I didn't stream capture anything. So I'm going to quickly make this video again. This is question 4 of the mock test 2 part 2. And in this question I'm asking you to do a few calculations on the data in these columns here. So I'm just going to cut and paste this straight into a spreadsheet. Okay, so be very careful because it's changed that look. And also this should be a 5.0, but it changes it to 5. So it's changed it from 2 sig fig to 1 sig fig. That's really silly. I'm going to format that to 1 decimal place, which will give me 2 significant figures. Okay, now I'm going to calculate the mean, and that is equal to the average, open bracket, highlight that, close bracket. That gives me the mean, 3.5. Okay, it's formatted it to the correct number of significant figures, which is good. Now I'm going to calculate the standard error, and remember what the standard error is. It's the standard deviation divided by the square root of the number of the items in the column. Okay, so it's going to be standard deviation divided by root 5. Let's do that. STDEVA, that's the function I'm going to use in my spreadsheet. I'm going to highlight that, being careful not to highlight my mean as well. I'm going to close that bracket, then I'm going to go divided by SQRT, open bracket, 5. Okay, that gives me the standard error. Drag that across and make sure these are formatted to the right number of significant figures. They've got 2 each. That's brilliant. Okay, now how do I work out the 95% confidence, the upper confidence interval, and the 95% lower confidence interval? Okay, so that is going to be, for the 95% upper, I spelled that wrong, it's going to be the mean plus a value of t from our t distribution multiplied by the standard error. So what is that value of t? Well, you can get that from your t-test distribution table. How many items are there? There are 5, so there are 4 degrees of freedom, and for a 95% confidence you're going to read across the 0.05 alpha value. Okay, so you're going to read down the rows until you get to 4 and across until you get to 0.5. That'll give you a value for t of 2.776. Okay, so to get the upper bounds, I'm going to get the mean. Oops, I'm going to go equals the mean plus 2.776 multiplied by standard error. Okay, 4.6, and then I'm going to drag that across. Okay, check that's the same. Check that's the same. Okay, they've all got 2 significant figures, and for the lower, I'm going to do the mean minus equals the mean minus 2.776 multiplied by the standard error. Okay, there you go. And I haven't formatted these, so I'm going to do that to 2 decimal places, or 1 decimal place to give me 2 sig figs. Okay, and then you have it. So that was part A of the question. Let's go back and read the question. I now need to figure out what this is all about. So B, using the paper that you have in front of you, that means graph paper, folks. Graph the mean responses and their 95% confidence indexes. So I'm going to plot on the x-axis just 3 columns, none, A and B, and on the y-axis I'm going to plot the mean as a little cross or a dot, and then I'm going to draw error bars which represent the difference between the upper and the lower confidence index for 95%. Okay, now I've taken a photo of that. I'm going to post it in the Vital along with this video. But if you look at that now, I'll be able to explain to you how you determine, yes or no, whether there is a statistical difference between each of these data sets. So I'm gonna, if you look at this, the first comparison I'm going to make is none and A. Okay, so if you look at your none error bars and your A error bars, And do they overlap? In other words, if you were to condense them onto one item in that y-axis, would they overlap? Yes, they would. So I'm going to put a y there. Look at none versus B. If I were to take those and overlap them, do they touch? In fact, no, they don't. And A and B, yes, they definitely do. So that's how you do that. Okay? Right, there you go. How do I stop this? There you go.